Let's take a look at number 17. Now we're going to apply what we've learned about polynomials and apply it to geometric problems. Okay, so in this case, number 17 asks, write an expression to represent the area of the rectangle below in simplest form. So we have a rectangle here, and we have to find the area of it. Okay, so the first thing we have to do is think about how do we find the area of a rectangle if it was just numbers. So we know area is always going to be, for a rectangle, it's going to be the length times the width. Okay, so they give us a length of x squared minus x plus 3 and a width of 4x plus 1. Okay, so now we have length times width. We know that's multiplication, so we're going to have to multiply these two polynomials. In this case, we have a trinomial. Reviewing our definition, we have three terms, and a binomial. So we have x squared minus x plus 3, and we have 4x plus 1. Okay, so we're multiplying a trinomial with a binomial. So in this case, we're not going to use the FOIL method. What we're going to do instead is we're going to distribute this 4x to everything in our original trinomial. And then everything with the 1, we're also going to have to distribute. Okay, so we're first going to do our 4x. So we're going to do 4x times x squared. And then we know this has a coefficient of 1, so if we do 4 times 1, which would be 4. Then looking at our product rule, it says when exponents with the same base, in this case x's, are being multiplied, we add the exponents. So this x doesn't have an exponent explicitly, but we're going to put a 1 to keep it the same. So we know 1 plus 2 is going to give us 3. So this becomes x cubed. Then next we have 4x times negative x, or negative 1. So now we have 4 times negative 1 will be negative 4. And then we're going to have x to the power of 1 and x to the power of 1, and that's going to give us x squared. Okay? Then our next one, we have 3 times 4x. So we're distributing that 4x to everything in the original trinomial times 3. So that would just be 12x. Okay, now we have to do the same thing for everything at the 1. But we know that's just going to keep it the same, but let's show our work. So we have 1 times x squared. So that would just be 1 times 1. And that would give us x squared again. 1 times negative x. Then we're going to have negative x. Then we have 3 times 1. And that's just going to give us 3. And now we're going to write this all on one line. So we have 4x cubed minus 4x squared plus 12x plus x squared minus x plus 3. And now we're going to have to do a review of combining like terms. So for our 4x cubed, we're going to say anything with an x to the power of 3 is going to get a triangle. See if we have any similar like terms. So we have x squared, no, x squared, no, x, no, and 3. So we know x cubed is going to be by itself. And then we're going to go to blue. So we have anything with an x squared, we're going to say is a square. Okay, so 12x, this x is to the power of 1. So we know our only like term is x squared. Going to a different color. So anything with just an x to the power of 1, we're going to say this is going to be a circle. So we have a minus 1x. So that's going to get a circle as well. And then our last one, our constants, or just a 3, a number, we're going to say gets a rectangle. Okay, so now we're just going to combine our like terms. So we don't have any other red triangles, so we're just going to bring down a 4x cubed. We do have two squares here, so we're going to have negative x squared. So I'll do that down here. Sorry, negative 4x squared plus x squared. So we know this is going to get a coefficient of 1. So negative 4 plus 1 would be negative 3. And now remember, when you're adding like terms, you just keep the base and the exponent. So negative 3x squared. Then our circles, we have 12x minus x. That's also going to get a coefficient of 1. So 12 minus 1 would be 11. And then we keep our x. So positive 11x. And then we just bring down our rectangle of plus 3. So our final answer is 4x cubed minus 3x squared plus 11x plus 3. Okay, now let's look at 19. Now we're switching our topic to factoring polynomials. Now we're going to talk about something a little different. So if 19 says 54 x cubed y minus 18 x squared y squared. Remember, these are all multiplied together. So this is one term, this is its own term, and then we have plus 27 x y squared. So when it says factoring polynomials, it says factor each polynomial completely. What that means is you're going to have to find the greatest common factor of the polynomial. Okay, in this case we have three terms, so we're trying to find the greatest common factor of a trinomial. Okay, so the first thing we're going to do is we're going to check each coefficient. So remember, coefficient is the number attached to a term. So in this case we have 54, negative 18, and 27. We're going to find the greatest common factor of those three numbers first. So we're going to have to make some factor trees. So we're going to do 54. We'll just leave it as positive 18, and then we'll apply the negative after, and 27. So we're going to have to draw some factor trees for each one. So I'm going to start with 27. Okay, so we're trying to find the greatest common factor. Which is the biggest number these three numbers have in common? So what are some factors of 27? Well, always start with multiples of 1. So we have 1 and 27. Then you can go through. You can see if 27 can be divided by 2, no, 3, and so on. So we're going to do 3 and 9. Okay, and then you could think about the other ones, but we're going to leave it like that for because there's no other factors of 27. Okay, so let's go on to 18. So same thing. We're going to start with 1 and 18, 2 and 9, and 6 and 3. In our last one, we have 54, so we're going to have 1 and 54, 2 and 27, 3 and 18, 6 and 9. So these all multiply to 54. So the reason I like doing factor trees is because now we can explicitly see which number they all have in common. Okay, so 54 and 18 have a 6 in common, but no 27. Okay, 27 have a 3, 27 and 54, excuse me, have a 3 and a 3, but 9 and 18. So we see that our greatest common factor has to be 9. So each one of these numbers can be divided by 9. Okay, so now we know that our factor is 9. I'm going to write that on the side here. Okay, now we have to figure out the x cubed, the x squared, and the x. Okay, so we have an x cubed, x squared, and just an x. And we're going to write these in expanded form to see what do they all have in common. So we have x times x. Okay, and now we can explicitly see that they only have one x in common between all of them. So we're going to pull out an x out of all those three terms. All right? And then our last one, we're going to check for our y. So this one has just a y by itself, a y squared, and another y squared. So we're going to write these out in expanded form. So we have y times y, and y times y. So we now again we can explicitly see that they all have at least one y in common. So we're going to pull out a y. So now we're going to see we have to pull out a 9xy. So our greatest common factor is 9xy. So now what we're going to do is we're going to write this out. And now we have to write, well, if we were to pull out a 9xy, how will we simplify that? So we're going to divide everything by 9xy. And we're going to write our final answer in our parentheses. So let's do 54 x cubed y divided by 9xy. Okay, so when you pull out a greatest common factor, you're dividing each term by your greatest common factor. So we know 54 divided by 9 is going to give us 6. Okay, now reviewing the quotient rule. The quotient rule tells us when exponents with the same base, in this case our bases are x, are being divided, we subtract the exponents. So we have x cubed divided by x to the power of 1. So we're going to subtract 3 minus 1. It's going to give us 2. So we have 6x squared. And then we're going to do y divided by y. So that's y to the power of 1, y to the power of 1. And that's going to give us 0. So we're just going to be left with 6x squared. Now if we go to negative 19 or negative 18, x squared, y squared, that's going to be divided by 9xy. So negative 18 divided by 9 is going to give us negative 2. X squared divided by x to the power of 1 is going to be 2 minus 1. That gives us x. Y squared divided by y to the power of 1 is going to give us y. So this is going to simplify to negative 2 times x and y. Then our last one, we have 27 xy squared divided by 9xy. So first we're going to do 27 divided by 9. That's going to give us 3. X to the power of 1 divided by x to the power of 1 cancels out because anything to the power of 0 is 1. And then y squared divided by 1 to the power of 1 is going to give us y. So simplifying this, we came up with 6x squared minus 2xy plus 3y. Okay, so reviewing how to factor polynomials, we're pulling out a greatest common factor. What does each term have in common? So in this case, we listed out our factors of 54, 18, and 27, and we came up with 9. Then we had to list out in expanded form x cubed, x squared, and x, seeing that they all have an x in common, and then a y, y squared, and y squared, seeing that they have a y all in common. Now, if you wanted to check your work, you could redistribute this 9xy back into the problem and see if you get your original. So we would get 54x cubed y minus 18x squared y squared plus 27x y squared. So your final answer would be 9xy times 6x squared minus 2xy plus 3y. Okay, looking at 28, now we have to divide a polynomial by a binomial. Okay, so we have x squared minus 14x plus 48 divided by x minus 6. Okay, so we have a trinomial at top. We have 3 terms. Now we have 2 terms. We have x minus 6. So how are we going to divide this? Well, the first thing we're going to do is we're going to simplify our trinomial as much as possible. So we have x squared minus 14x plus 48. So this is a factoring problem using what multiplies to 48 and will add to negative 14. Okay, so you have to think about this on the side. We can do another factor tree. So we have 48. And we have to think about what will multiply to 48 and add to negative 14. So we know 48 will be 6 times 8. But how are we going to make that equal negative 14 if we were to add them? Well, we're going to make them both negative. Now, if I was to do negative 6 plus negative 8, that's going to give us negative 14. Okay? So now with that factor, we can rewrite this as x minus 6 and x plus 8, or x minus 8, all divided by x minus 6. And now this is much easier for us. We can see that x minus 6 divided by x minus 6 will cancel out. And now it'll leave us with a final answer of x minus 8. Okay, so when dividing polynomials, you always want to simplify your numerator as much as possible. So you can see that we have a factor that will cancel out. Okay, so you're looking for what can we cancel out to make this a simplified polynomial.